Hello, this is Ms. DB, and in this video we are going to go over some of the problems from the 7.5 worksheet on using proportional relationships. So more similar figures, more proportions. Our first, there's a definition here of what indirect measurement is. It's any method where you use formulas, similar figures, and or proportions to measure an object. Anything other than actually getting a tape measure out and measuring it is indirect measurement. So in this first example, we have a student and has her shadow there, and then there's this giant fake statue of a pineapple and its shadow. And you can use indirect measurement because the sun has rays that are parallel, so AB is parallel to DE, and then we have right angles. So we can say that we have corresponding angles and right angles, so we can use AA to know that we have two similar triangles here. So we get AA. So therefore, we can use, since we know these two triangles are similar, we can set up a proportion and solve this problem. Now, because the pineapple shadows is 8 foot 9 inches, we need to convert that to just inches to be able to finish our work. Because with the standard measurement, we can't just say it's 8.9. That's not true. So we have to either change to feet by going 9 divided by 12 is so many parts of a foot, or you can just convert to inches, which is probably a little bit easier. So 8 feet is 8 times 12, and then add the 9, so that's 105 inches. And then the girl's shadow, to change that to inches, is just 2 times 12 is 24 inches. So that's easy enough. And we also need her height is 5 foot 4 inches, so we'll also convert that to inches, and they did that and got 64. And then you plug all those parts in and solve your proportion. So let's look at a couple problems. Number 1 is just like that. You have a student standing next to a statue. His height is there and the length of the shadow. And then we're trying to find the height of the sculpture, and its shadow is also given. Now these are not to scale. It's just made to fit on your page a little bit better there. So again, step 1, change to just inches. This will be angle again, because with the rays of the light, I don't know if they're outside, it's the rays of the sun. If they're inside, it's the rays from the light. Those would be, we're assuming, coming from up here, so that these are parallel. So that means that corresponding angles are congruent. So we have angle again, and then you're going to write a proportion and solve. So for your proportion, let's call this H. You could do this over H equals this over this, but first change to all inches, because you can't work with feet and inches in the same problem when it's part of one dimension like that. You could, if it was just feet, and inches, you could work with that, but you can't work with it when it's mixed together in one picture. And then pretty much the same thing for the dinosaur here. We're going to try to find the height of this dinosaur. And we know the height of this Amir, and we know his angle from here. These two angles are congruent. And we know the height that Amir is standing from the mirror, or the length, width, whatever you want to call this dimension, and also this one. So we've got a lot of given information. We know that these two triangles are similar because we have two right angles and then two congruent angles. These are all given. So they're angle because you have two pairs of congruent angles. And then you're going to write a proportion and find the missing side. Now this problem here is just like those, but it looks more complicated. So let's work out what we have here. We have two triangles here. We have triangle ABC here, and then we have triangle ADE up here, the bigger triangle. So they're overlapping triangles. You could draw them separately if you wanted to, but we do have two separate triangles here. So we have, this is like a platform for an outdoor concert. So here's the scaffolding here, 2 layers of scaffolding. And the first platform right here is 8 feet 2 inches off the ground. The second one is another 7 foot 6 inches above the first one. So you may need to find the height overall, which would be here. You could add those two together. And the shadow of the first platform stretches 6 feet 3 inches here. So first of all, how do we know that these two triangles are similar? In other words, how do we know that triangle ABC is similar to triangle ADE? And the hint is that the sun's rays are parallel. So this is going to be the same as the reasons that your other two triangles are similar. We have a shared angle here. So we know that angle A, actually let's call it the way we should. This would be angle CAB is congruent to angle EAD. You could either say by the reflexive property, or you could say that these are both right angles, so the right angle congruence theorem says that all right angles are congruent to each other. But since they're shared, they're the same exact angle, then that's the reflexive property. And angle CBA would be congruent to angle EDA by, these two angles are the same, by corresponding angles postulate. So we can use angle to say that the two triangles are similar, the angle similarity postulate. Okay, and then B is just going to be solving the same as we did the last two, number 1 and 2. Find the length of the shadow of the second platform in feet and inches to the nearest, right here. We have to find this A to D, from here to here. So even though the two triangles are overlapping, we're going to do the same steps as we did before. So we're going to change these to just inches, and then set up a proportion, and then we'll answer the question. So let's see, I'll do this problem with you here. I need a little more room though before I get to C. I am going to first change to all inches. So 8 foot 2 inches would be 8 times 12, because there's 12 inches in a foot. 8 times 12 plus the 2 more inches. Okay, so that's 98. So this is 98 inches. And 7 feet 6 inches, 7 times 12 is 84, plus 6 is 90 inches. And then we have 6 feet 3 inches. I have to change that as well. So 6 times 12 is 72, plus, it was 3, wasn't it? 72, yeah, it was 3, so that'd be 75 inches. Now I do need to know the height from E to A, so EA would be 90 plus 98, so 188 inches for this whole height. So now I'm ready to set up my proportion. I'm going to use, let's see, how should we do this? We're looking for this. I'll use the height of the short one, 98, over the shadow of the short one, 75, is equal to the overall height of the two together, that's EA, that's 188, over the shadow all the way across, which is AD, or I'll just call it X. So here's my proportion that I'm going to use, and then cross products are equal. So 98 times X is going to equal 75 times 188. And I'll get my calculator out. 75 times 188. Whoa, that's too many 8s. 188 is 14,100. I just want to double check that I didn't have too many. 14,100. So 98x equals 14,100. Divide both sides by 98. And I get 143.88. 143.88 inches. Now, This asked me to write the answer in feet and inches. I have my answer in all inches. Here's how you would figure this out in feet and inches. Take your 143, actually let's round this to 144. 144 inches. I'm going to take my 144 and divide by 12. So 12 divides into 144. Well, 12 times 12. So this is 12 feet. Now it's slightly less. They asked me to go to the nearest inch though, so that's okay to round this to 144 inches. So this is 12 feet from here to here. All right, now there's one more part to this problem. It says that on top of this platform, I've got some guy standing here. And he is 5 foot 8 inches. And he's standing on the top of the second platform. And now they want us to do one more line and figure out the length of the shadow, the scaffold, and the technician cast in feet and inches. So now we're looking for all the way from here to here. So we already know that this is 188. I need to add to that 5 feet 8 inches. Let's change that to just inches. 5 times 12 plus 8. 68 inches. So I need another 68 inches because he's 68 inches. And when I add 68 plus 188, I get my new height of 256. So now I'm 256 all the way from here to here. 256. All right, so all the way is the height of the whole thing is 256. We already know the height of just this first platform is 98, so I could use that. I'm going to use the little triangle and that big giant one. And then I could use the shadow, which is what I'm trying to find. I'll call that y because I used x in the previous problem. And this shadow from here to here is 75. So now you solve that problem, and you'll know the shadow from this red line from all the way from here to here. All right, so moving on, scale drawings. I'm sure you've worked with this before, but that's when you obviously can't draw the whole city, so you make a smaller version of it. It's called a scale drawing. And the scale can be used as one of the ratios in your proportion. So in this one, 1.5 centimeters to 300 meters, see that part right there is equal to what they told us that the scale was. So we use that as one of our ratios in our proportion. And then we just use cross products and solve. So these aren't going to be very difficult. In this one, the real building is 45 to 28, 45 feet long, 28 feet wide, and they want us to find a scale drawing using these scales. They want us to find the length and width of a scale drawing. So if our scale is 1 to 1, that 1 inch is to 1 foot, then this one's going to be really like, that's just 1 over 1. So to find the length, you'll have to do this twice for each one. To find the length of it, we would use the scale width would go here equals 45. And then you'll cross multiply. Well, you'll know that that's going to be equal. If the room is 45 feet long, the drawing would be 45 inches. And then you do the same thing for the width. So for each one of these problems, 4, 5, 6, and 7, you'll do 2 parts. And this will be the one of the ratios, so 1 to 2. So you might be able to figure these out in your head. So we're looking for the length of the scale drawing, and we know that the actual is 45. So you would cross multiply and find that the length of this would be whatever you get. Let's see, 2x equals 45. So 45 divided by 2 is 22.5. And then you would repeat this for the width, except you would have, I'll use W for width, and that would be 28, but you would use the same scale of 1 to 2. And these will be in inches. So you do the same thing, except you'll find that this one is 14 inches. 2w equals 28, divide by 2, and you get your answer. So for each, now when you do number 7, your ratio for your scale is going to be 1 over what? 6 feet 8 inches, we need to change that to inches. Or you can change to feet, but you can't have it in mixed parts like that, mixed dimensions like that. So we know how to do that. You take 6 times 12, that's 72, and 72 plus 8 is 80. So 1 over 80, this is in inches now. And then that means that this, though, is in feet, so that's going to be a problem. Let's do this one. I'll show you how to change this in to feet instead. So to change this to feet instead, to make this problem work better, what we're going to do is take the inches part and change that to a decimal part of a foot. So what is 8/12 as a decimal? 0.666666. So this would be the same as 6.6666666. Put as many 6 as you can when you do this on your calculator. So that's the scale, and I'm going to then use the x for my length over 45, and then this will give me my answer the correct way in inches. So 6.6666x equals 45. So 45 divided by 6.666, just put it in a whole bunch of 6's, is equal to 6.75. So 6.75 inches. The more 6's, the closer you'll get to that answer. And then you'll repeat this for the width. All right, and then we have a hot air balloon. So again, we have the width here. And this is the height. I guess we'd call this the height. And an actual hot air balloon is 26.8 meters tall. So they're giving us the height of the actual. We know the height of the scale drawing is 3.2, and then you are trying to find the width, and we know the scale drawing's width is this. So you just set up your proportion and solve it. All right, and then the last part of this worksheet is on the proportional perimeters and areas theorem. This is simple but important, so don't forget it. We'll use this over and over again in the coming chapters. If two figures are similar, then their similarity ratio is A over B. Then their ratios of their perimeters is also A over B. If this big triangle is 3 times as big as this, its perimeter will be 3 times as big. But not true for areas. The area, you have to take the similarity ratio and square it. If you say that their areas are the same as their similarity ratio, you are wrong. It's the similarity ratio squared. So they give you the perimeter of the small rectangle, and you have to say what is the perimeter of the big one. Well, we know that the perimeters will be the same as the similarity ratio, and we can find the similarity ratio because they give us 2 side lengths, and that will be equal to the perimeter of the small over the, we don't know the perimeter of the big, I'll just call it P. So you solve the proportion and you'll be good. But for area, you have to take the similarity ratio and square it. Now these are big numbers. Let's simplify our similarity ratio before we do this. 10 over 15 simplifies. We can divide each of these by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. We can square that to get a much easier to work with number. When you square a fraction, you square the numerator and you square the denominator. So the square of 2/3 is 4/9. That's what the areas will be. You'll use that for your proportion for your areas. So the area of the small one was 40, and then you'll use that to find the area of the big one. So you still have to solve those. And then there's just another example problem similar to that. All right, thank you very much. Have a wonderful day.